Hello, everyone, and welcome to this webinar on accuracy and time saving featuring one of our valuable customer, First Alpine. First Alpine Stall GmbH operates a fully integrated metallurgical plant with all process stages at one location. Cooking plant, blast furnace, steelworks, hot and cold rolling mill, as well as galvanizing and coil coating. My name is Jérôme Alexandre Lavoie, and I'm joined here today with my colleague Olivier Plamondon, Technical Product Manager at Creaform. Before we get started, here are a few housekeeping notes. You can ask questions during the presentation in the question tab of your GoToWebinar control panel. We will answer your questions at the Q&A session at the end of the webinar. As I mentioned, we will be discussing First Alpine case study today, and to be specific, we will see how accurate 3D measuring devices can lead to great benefits. It's important to mention it because even if a company like First Alpine have been using 3D measuring devices for years, it is not the case for everyone. In fact, a recent survey has shown that when asked what was the biggest objection prior the adoption of 3D scanning solution, 27% of the respondents said that they had trust issues with this type of equipment, not seeing it as a reliable measuring tool, or they simply did not have enough information or knowledge about 3D scanning technology. 38% said that they needed to prove return on investment, while 23% said that they thought the process was simply too long. These three categories carry 88% of the 171 survey participants. 171 participants that are now using 3D scanning technologies, just like First Alpine. So for the rest of the presentation, we will see how to overcome these objections like these participants. Let's start with the price versus the performances objection. These days, there's a lot of people getting in contact with Creaform asking for quality control or automated quality control solutions. Whether you're thinking about automation or not, we feel very strongly that the key of building a strong financial case is to consider multiple factors that impact your businesses. Looking at the first year's savings will give you very quickly a good idea of the potential value of 3D scanning solution of a 3D scanning solution can bring for your organization. Adopting a 3D scanning technologies can bring value in two different forms: cost prevention or revenue growth. Each categories have different buckets that you can consider. One of the most obvious cost prevention items is direct labor savings. Well, when calculating this type of savings, it is important to take the direct wages plus the compensation in the calculation. Take the following example. Imagine a company moving towards 3D scanning from a CMM or manual tools measurements. This company will gain significantly in productivity for quality control, say from 50 to 75%. So for an employee working 40 hours a week, 50 weeks a year, it's 2,000 hours. Saving 50% of that, it's 1,000 hours that can be deployed to value-added tasks, including maybe more measurements or measurements analysis to reduce scrap and rework, which is another important element that contributes to the cost prevention. The cost prevention of quality issue includes the required additional manufacturing labor and cost to rectify a problem. It should also include the cost of quality issue that cannot be reworked. Top performers around the world are around 0.6% of business revenues. Worst performers are around usually 2.2% of business revenues and sometimes more. There are other categories that are very important, of course, such as floor space reduction. Those of you who are working with checking fixtures probably know what I'm talking about. And finally, employee retention, which in today's context is crucial for most businesses. Finally, 3D scanning can help with capacity gain and customer retention. But let's go ahead with a quick simulation. Let me click here. I'm going to show you a small calculator. So what we have here is all the buckets that I've just talked about, okay? Cost prevention and also revenue growth. So if for our simulation, we say we're going to save 1,000 hour at, let's say, $40 per hour. That includes wages and compensation. And we're gonna say, well, we want to save 1% of a $5 million business. And let's see what kind of savings we can get for the first year. Let me enter my information. Say that, for example, I'm interested in a portable 3D scanner. Just with this simple simulation, I can see that I'm saving $90,000 in the first year only, and I have not even input the savings that I could have if I assume that I will have some revenue growth. Say, for example, I gain more customer in a year. Now, if I go back and change the simulation for a $50 million business, and I calculate it again, I ended up with a 540,000 saving in the first year only, which could even make me think that automation could be a good fit for our organization. Which brings us to our first poll of the day. Okay, our first and only poll of the day, I should say. Does your organization have interest for automated 3D scanning? Are you not interested? Are you interested but for desktop automated 3D scanning? Are you interested for offline / at-line automated 3D scanning? Say, for example, replacing a shop floor CMM? Or are you interested for inline application, putting 3D measuring devices part of the production line directly? Let me look at the result. I can see the result coming up. We have maybe a couple of few seconds now. We have two major categories that are seems to be more important. Let's stop the poll right now and look all at the final results. What we have is a 17% of the people said that they are not interested. 33% said that you are interested, but for desktop automated 3D scanning, 33% said for offline or at-line application, and 17% said that you're looking for an inline application. This is very, very interesting. Now, let's move to the second major objection from adopting a 3D scanning solution. In this following section, we will talk about the confidence and knowledge that people have in 3D scanning. This objection directly relates to the accuracy and reliability of 3D scanning technologies. For voestalpine, both reverse engineering and quality control process require a flexible handheld system with greater accuracy. In addition, they feel that the system should be able to scan surfaces of all kinds, including shiny surfaces, without any problem while being used directly in the production, and should therefore be insensitive to oscillations and vibrations. So the question is how to choose the best technology to deliver accurate measurements in shop floor conditions. Well, my colleague Olivier will answer this question by showing you one of the key tests that absolutely needs to be done to truly understand the accuracy that a metrology system can deliver. Olivier?
Thank you, Jerome. Indeed, assessing the true volumetric accuracy is key to making sure not only we choose the right 3D scanner, but that we also end up being confident in the measurements. And in order to demonstrate that, let me present you some results of a test we performed with a volumetric artifact. First, let's see why volumetric artifacts are the best way to assess the volumetric accuracy of a device. As you all know, the first information we get from a 3D scanning company is a specification sheet, which lists the claimed performances of a device on paper, such as the accuracy, resolution, scanning area. But in reality, are those performances always delivered? Well, we all know the answer to that question, right? That's why we need to validate them. And more specifically, the accuracy is the most important one, as it is the most valuable for companies who are doing serious quality control, such as Voestalpine. That volumetric accuracy can either be a stacking error formula like the one you see on screen. It basically means that the larger the part, the more error is accumulated, and it is typical of self-positioned 3D scanner that rely on reflective targets for their positioning. Or it can represent a tolerance inside a measurement volume for optical CMMs, like the Metroscan 3D, or articulated arms, for instance. In that case, we usually see one value, like 80 microns, which means that the accuracy is guaranteed in the whole measurement volume. Now, what is the best way to assess the volumetric accuracy? Well, typically, and I'm sure you're all familiar with this, we measure ball bars. A ball bar allows to validate one dimension of different typical lengths, but the problem with a ball bar is that it only validates one dimension. It's only a length, right? That does not constitute a volume, and also it does not accurately represent the parts that are going to be measured. So this is why volumetric artifacts are the best way to validate a volumetric accuracy specification. They allow measurements in three directions, X, Y, and Z. Hence, it is a better representation of a measurement of a part. The volumetric artifact we have used for our test is the Inora artifact. This artifact is basically 6 ball bars in one, as 4 spheres are linked interdependently to one another in the shape of a pyramid. Because of its design, it is said to be climate invariant. The bars are made of carbon fiber, from which the end pieces are designed to adjust to the thermal expansion of the spheres. The spheres are made of grade 5 stainless steel, and their nominal diameter value are built to be within 1/100th of a micron. All in all, it's a serious metrology grade artifact. As you can see, it allows a more representative way of validating the volumetric accuracy of a device, since it emulates the actual volumetric measurement process of a part, so in other terms, what the customer will actually be doing in the end. Now, let me demonstrate why using a volumetric artifact is key when choosing a 3D measurement solution, by first showing the results of 2 types of scanners on the Inora artifact. Creoforms is Metroscan Black Elite, a 3D optical CMM, and a 10 feet articulated arm with a 3D scanner attachment. These scanners are designed to scan large parts. And for your information, the Inora artifact comes in many sizes. So we use the largest one for our tests, of which all bars are 1500 millimeters or 5 feet long. So 6 distances measuring 1500 millimeters. It's the one we've seen on the field the most, and it is the most challenging. But of course, a customer should be choosing the one that is the most relevant for their part size. The workflow was the following. The spheres of the artifact were scanned at 0.5 millimeter resolution, or 20 thou, and scanned 5 times per device. We also did 2 types of acquisition, without leapfrog and with a leapfrog, so moving the measurement device to complete the acquisition. An inspection template was then used to extract the data, so the distances between the spheres. And finally, a report was created to gather the average deviation and the range of all distances. And before we take a look at the results, just for information for the upcoming graph, please note that the 6 distances are identified D1 to D6, and distances 1, 2, and 3 are the ones on the XY plane, so on the floor, and distances 4, 5, and 6 are in the Z direction. So here we're looking at the average accuracy results of both devices for the 5 repetitions. So in blue, we have the Metroscan, and in green, the articulated arm. The dotted lines represent the volumetric accuracy specification of each devices. So what we can see here is that both devices are within specification. The average deviation of all distances for the Metroscan is 22 microns, and for the articulated arm, 33 microns, about 50% more. Already, this gives us an idea of the performance we can expect from those devices, and this is already more valuable than a specification. These results are expected from serious manufacturers of metrology-grade devices. But do the same conclusion hold for the same test, this time performing a leapfrog or volume extension? Well, not exactly. The Metroscan still holds its specification promise of 78 microns, but the arm fails to deliver on half the distances. In average, that makes 28 microns for the Metroscan and 52 for the arm. Again, this is not something a spec sheet would have told you. Now, if we put the no leapfrog results next to the leapfrog results, we can analyze the impact it has on accuracy measurements. It is expected that a leapfrog will affect negatively accuracy results, but what is important is that the customer knows the magnitude of that impact. He will thus be able to determine if those results are acceptable to them. And if they are, they will be confident that the device will be able to deliver when they will be needing it. And that brings us back to our initial question. Why is measuring a volumetric artifact important prior to purchasing a 3D measurement device? Well, first, a company like voestalpine needs to make sure their measurements are accurate, and one of the reliable ways of doing that is by using a volumetric artifact. In our case, the measurements have been made in the lab, but what the inner artifact allows is that it could easily be deployed on the shop floor. As you know, shop floor conditions can be difficult for 3D scanners, as there can be vibrations and temperature changes. So it can be then even more valuable to request the test to be performed in their future and actual measurement conditions. Next, we could see the impact that the leapfrog had on the measurements, and that in the case of the articulated arm, the results would not have been acceptable for voestalpine. As you know as you can see in the background pictures right now, and as you will see in an upcoming video, they are measuring large parts, and it wouldn't be surprising if they would be needing larger volumes for some of their projects. Moreover, in the case of this specific test we conducted, we have to mention the simplicity of the leapfrog of the Metroscan versus an articulated arm. So not only does the process provide more accurate measurements, but its specific dynamic referential allows for a simple and quick volume extension, thus saving time and effort, which is crucial for shop floor measurements. Both of these assertments amount to a very important aspect of purchasing a new device to perform shop floor quality control, gaining confidence in the product. By assessing the volumetric accuracy using a volumetric artifact, a company like voestalpine would be confident in their measurements. And confidence also translates into speed over time, since it allows companies to make decisions faster about future projects, thus save them time. Now, maybe some of you were already wondering about the next topic. Isn't there an important criteria for serious shop floor quality control? There is: repeatability. Indeed, repeatability or precision is as valuable as the accuracy itself. Their measurements may be accurate, but they might not be repeatable, which is why it's important to verify these criteria as well. Here, I'm showing you a comparison graph right away of both devices and both scenarios. So you have without leapfrog on the left and with leapfrog on the right. Again, we can easily see the arm is less repeatable overall, with an average of 36 microns versus 12 only for the Metroscan, and also the great impact of the leapfrog with the arm averaging 97 microns versus 52 for the Metroscan. So this information, combined with the accuracy results, really gives us a lot of valuable input, which helps guide a company like voestalpine making a better decision that will pay over time. Now, we did the same test using portable 3D scanners this time. Another type of scanner voestalpine is using to perform quality control and reverse engineering. Here are the results for the HandyScan Black Elite and an equivalent portable self-position 3D scanner. For both these devices, we used the same setup. We designed and built an aluminum structure to fit inside the artifact to allow the use of positioning targets. 3D printed parts were also added near the force spheres locations to ensure enough targets were seen from many directions while acquiring the data. Then, using the same simple workflow as before, we performed 5 repetitions per device and also doing a sequence without the use of photogrammetry and then performing a photogrammetry. Here are the results. So same as before, we can see the average results of the 6 distances of both devices with the HandyScan in blue. As you can see from the specification, the dotted lines again, the results of the portable scanner are way off. As for the HandyScan, they are actually excellent. We're talking about 26 micron in average for all the distances, well below the spec, and 189 microns for the equivalent 3D scanner. So what went wrong here with that other scanner? Well, it so happens that in the specification sheet, they do have a stacking error formula, which for a 1.5 meter artifact equals 72 microns accuracy. But when you dig further in the technical documentation, you realize they mention a photogrammetry is recommended for parts larger than 1 meter to ensure the accuracy. The problem here is that first, the information is not easily accessible like it should be, so in the spec sheet, and also a 1 meter part today is not considered a big part. And since the inherent behavior of a stacking error device is that it accumulates error the more you scan, you can imagine the results for a 2 or 3 meters part, for example. This alone is a strong argument for the very first reason we mentioned of why it is important to verify the specification and for the use of a volumetric artifact. It ensures that such flaws are caught during the purchasing process and not after. Now, let's see if the results are indeed better when performing a photogrammetry. Well, almost. Well, at least we can see that in order to use the other portable 3D scanner for 1.5 meter, a photogrammetry is indeed needed. But even so, it fails to fall within specification. The average is 16 microns of accuracy versus 13 for the HandyScan. With such results, I'm not even shy of comparing the HandyScan without the use of photogrammetry versus the other scanner with photogrammetry. This brings back into light the simplicity aspect. What this graph is not showing is how simpler it is to directly scan the part rather than having to place photogrammetry targets, take pictures, create the 3D target model, etc. So, in conclusion, the best way to determine the ultimate technology that delivers accurate measurements in shop floor conditions is to use a volumetric artifact such as the Inora tetrahedron. Now, it's time to hear directly from First Alpine and discuss the last objection people had, the speed of the 3D scanning processes. So we're about to play a video, so be careful as the window can pop up behind the GoToWebinar.
voestalpine Stahl GmbH is the lead company of our steel division, the largest of the 4 voestalpine divisions. We're one of Europe's major steel producers, and our products are used in the automotive, household appliance, electrical, and manufacturing industries. Here at the site in Linz, we operate a fully integrated metallurgical plant consisting of several blast furnaces, a steel mill, a hot rolling mill, several cold rolling mills, and various galvanizing and tempering plants. In the Electrotechnical Center, we're mainly responsible for the 3D measurement technologies used at voestalpine Stahl GmbH. 3D metrology has been in use at voestalpine for quite a number of years now. We use terrestrial laser scanners to survey combustion chambers and log any damage. We decided on a new measuring system because we're looking for a solution that offered better performance for different surfaces, increased measurement accuracy, and improved portability for use in plant areas. A major area of application for Creaform systems is quality control. In quality control, the scan data is compared with the target data. This way, we're able to determine if the actual components deviate from the technical drawings. Another area of application is reverse engineering. We create technical drawings for spare parts based on the scan data, which we can then manufacture in-house. Using a combination of the HandyScan 3D, Metroscan 3D, and HandyProbe, we cover a very broad spectrum of applications. These range from small components, such as scanning gear wheel profiles down to millimeter accuracy, through to logging entire plant components. We've been able to achieve significant improvements in terms of accuracy and a reduction in measurement times. The performance of the 3D scanners with different surfaces has been surprisingly positive. Creaform measurement systems offer new possibilities in our engineering value chain. In the future, we will increasingly use this measuring equipment for reverse engineering, retrofitting, and the quality control of components produced in-house or externally. With Creaform's technology, we are further contributing to the sustainability and technological best practices at voestalpine.
Okay. Now, yeah, Great video. Now, in conclusion, trust in 3D scanning technologies is built on accurate measurements, which enables a wide range of measurement tasks. Volumetric artifacts are a great tool to validate the real performances users can expect from a device. Finally, when you are working with an accurate device, it creates a gain in productivity, which leads to a shorter period of return on investment period. Another important factor that leads to productivity is working with portable devices. Being able to carry out a device anywhere significantly reduces the time and complexity to access the results. I want you to remember that Creaform is a technological leader, not a follower. Creaform was founded because other measurement technologies defined as portable were simply not suitable for shop floor environments. We aim to tackle our clients' most difficult challenges and are eager to push the envelope. Our company is headquartered in Lévis, Quebec, and we have now 15 offices in 12 different countries to meet the demands of our global customers with local service, language skills, and spares inventory. Creaform is 20 years old this year and has never stopped innovating. We aim to continue to create a better tomorrow and deliver extraordinary value for you, our customers, for the next 20 years to come. Let's move to the Q&A period. There were already some questions that came in during the presentation, but you can still ask your question in the GoToWebinar panel in case you didn't have time to do so. We'll do our best to answer all questions. So let's jump right in. Just gonna move here. A very easy question. Is the saving calculator showed will be available to anyone? Absolutely. We are going to, I think our helper here, Emily, I think she has posted the link in the chat. So if you do have, or if you want to play with the tool, you can click on the link. We will add it to our thank you email as well. So you will have the link. If you cannot access the chat, you will have it in the thank you email in the upcoming days.
I think also someone was didn't see enough results to their likings. He is asking, you only mentioned the volumetric accuracy results. Do you also have the diameter results? We did. It was just less relevant for this presentation to show them. But if you're interested in seeing all of the results of the test we performed, you're welcome to send a message. I will send that information to you in private.
There's a question here about in the presentation you mentioned the simplicity of Leapfrog with the MetroScan. How simpler is it exactly?
Well,
great question.
Yeah, great question. Do you want to answer it?
I can answer it.
Okay.
That's fine. So we have seen it a little bit in the video, the first Alpine video. We have seen the optical reflectors. So the system, the MetroScan 3D system, is worked with the what we call a C-track, which is a dual camera sensor. The C-track look at the MetroScan, but it also looks at some reflector that you can put on the part, reflectors that will be used to compensate for floor vibration or oscillations, but can also be used when you want to move the device and extend your measuring volume. So all you have to do is put these reflectors on the part you are measuring and you get rid of the vibration, but you also don't need to go out and measure tooling balls or other artifacts to move your device and still be in the same reference frame. You can just look at your reflectors, move the C-track, extend your volume, still look at your reflector, and you're already in process to measure or continue the measurement. So it's extremely simple that way.
All right, another question here. What are the actual accuracy specification of the MetroScan 3D? It's a good question. By the way, all of this information is easily accessible on our creoform3d.com website. But for the Metroscan 3D, for the volumetric accuracy, we have two values. One in a smaller volume, you have 64 microns accuracy in that smaller volume. And in the bigger measurement volume, we have 78 microns accuracy. Again, that's the volumetric accuracy. And for local also accuracy, the value is 25 microns. Again, all of this information is easily accessible into this tech spec section of our website.
Thank you all for your great questions. We need to make a cut here, but for those of you who had questions that did not get answered, be assured that we will be happy to reach out and follow up on that. In case you arrived later, you had sound problem, this webinar is being recorded and will be available on our website shortly. You will receive a link in the upcoming days. Thank you for attending this webinar today. You have been a great and very attentive audience. One last thing, after the webinar ends, there will be 2 quick questions popping up for you. This will help us to prepare future webinars with topics that are interesting and relevant for you. There's also a comment tab where you can add some comments on the webinar or ask other questions in case you didn't have time to do so. Thank you very much once again. Have a great day.